Okay, hi everybody. This is Iftach from CloudZone here. As said, we are going to do this session in English for the benefit of some of our attendees. I hope it's fine by everybody. I'll try to speak as clear as I can. Let's start. So, first of all, I'm really sorry that this session is not frontal. The plan was, but there is a direct instruction because of the coronavirus to reduce the events, and we got instruction from above to do this as a webinar. So first of all, I'm sorry. We are going to talk today about AWS App Mesh. It's the managed service for a service mesh by AWS. We are going to cover the ecosystem around this solution. It means what is the problems that leads us to needing a service mesh, and some of the integrations in the platform of AWS. And we will talk about cool things, about cloud native things, and hopefully this will be insightful for everybody. Short words about myself. I'm working for CloudZone for the past 3.5 years. I was a developer for 5 years in my past, and then I turned into DevOps, and today I'm leading innovation in CloudZone. A word about CloudZone in the context of AWS. So CloudZone is a premier consulting partner of AWS and a managed service provider as well. We are holding several competencies, among them, and more relevant for today's talk is DevOps competency and security competency. We are a Matrix company acquired by Matrix some years ago. And in more of the context of service meshes and Kubernetes and containers and so on, so CloudZone is also a CNCF, which stands for Cloud Native Computing Foundation. For the ones who still don't know the CNCF and you are dealing with Kubernetes and tools like Helm and Docker, so I recommend you to get familiar with the CNCF landscape. CNCF is the body today, the foundation that holds all the CI/CD processes for Kubernetes code. We are certified by this group as a KCSP. It means that almost all of our DevOps engineers are certified for Kubernetes, and we are also silver members, and we are attending all kinds of product promotion from Sandbox to other more mature stages. So this is my tip for you. Whoever don't know the CNCF landscape, please do. Another thing regarding the coronavirus, so whoever was supposed to attend the KubeCon in Amsterdam, so most likely it's going to be canceled for the same reason that the Ignite was canceled. So we are all enjoying under the coronavirus. The agenda for today, so we will talk shortly about microservices challenges. I won't go deep in this. This is pretty clear, and we're talking about high-level challenges and what organization did with microservices prior to service meshes or service meshes solutions. So it's something general about the service mesh and microservices. We're not talking yet about App Mesh or Istio or anything else. We will talk then about the service mesh, about the concept, what is the control and data plane and how they work separately. And then we will drill down into AWS App Mesh. We will talk about its architecture. We'll talk about its features and heavily about the integration with AWS, specifically about EKS, X-Ray for distributed tracing, and Cloud Map for service discovery. We have a few slides at the end for comparing App Mesh with Istio. We have Istio users in the crowd, so also if there's some questions at the end about Istio, please write in the chat. I'll do my best to answer as much as I can. So as I said, about the food and drinks we are missing, it was supposed to be in the agenda. So of course we are sorry, but we are going to make some kind of a lottery, and we will provide 2 Nerf guns, as you see in this picture, as a present among the participants. So hopefully one of you will get this, like the one who gets it. So this is a gift for us for not making food and drinks. So about the rise of microservices. So according to research, I wouldn't call this a research, but according to some details from 2019, 63% of the enterprises. Just a second.
I want to press the 3 dots and then the audio connection to hear the session because sound better.
Okay. And now they hear.
They need to enable the audio connection.
Okay, where is it?
It's where the 3 dots.
Sorry, I have instruction to give you instructions about some people cannot hear us. Which one? This one?
Yes.
But they see the same as me?
It's the same as Iftach. Audio connection.
Okay, for the guys who don't hear, or for the ones who don't hear me, there is a 3 dots button more, I think, of WebEx, and then you can have audio connections. Hopefully you will manage this by yourself. If not, please tell again to Liran, and we'll try to help. So again, I was saying, so according to 2019 research, 63 enterprises are adopting microservices architecture. We see this, okay? I'm seeing it for the past 2 years. There's microservices everywhere. I'm not going to go now when it's good, when it's not good, how to go into design of breaking monolith. This is not the focus of this talk, but this is just a fact. We are seeing this everywhere. Greenfield applications are rating as microservices. We see banks, we see insurance companies, we see enterprises in general adopting Kubernetes and breaking legacy applications into microservices. So we are not going to state what's hard in it, or I mean software design wise, but we will talk about the infrastructure challenges and how we can solve this with a service mesh. So the benefit, as many people know, this is polyglot teams. We can make use of different experience or expertise and have teams develop microservices with different stacks. We're talking about smaller chunks or smaller units which we update into production. This increases our the speed of our feedback cycle. We can test things better in production. We can scale workflows efficiently. This is clear. Where a microservices that needs specifically more to attend more requests, it can scale by itself, not causing scaling of all the components of the composed application. So all of this, of course, leads to also reduce risks in deployment into production. I would say that all of the above is indeed hard to do. It's hard to do, of course, software design wise, but also infrastructure wise. So let's talk about some of the challenges. So we know that microservices are distributed. They run on top of different virtual machines, for example. They're spanning different network segments, and they communicate over network. This presents much more difficulties, such as latency and outages, which can break a distributed application, of course. Applicative-wise, we're talking about contracts between services that can break. End-to-end tests that now involve deployments of multiple applications. And of course, as we said, network can be flaky, or a service can be in and out age, and so on. Monitoring is harder, right? We need now to understand all of the segments, all of the parts of the entire microservice to understand the problems presented by the entire set of components. And of course, acquiring knowledge of new generation tools. We usually associate microservices with modern applications, with containers. And this usually presents the need to study and to get familiar with many tools. I'm sure many of you know that. Second. All right. So the basic challenges, we are sending a request to a front end microservice. We send it to a user microservice. It sends it maybe to some database or other service, and at one of the services there is an error for any kind, and this error is propagated all the way back to the user. The user waited. It took maybe some time because this was outage and there was a delay and not necessarily an error, and the overall experience for the user can break or be not as good. We're talking about as part of monitoring, if we are talking specifically about tracing, about really seeing one request and examine it end to end from the beginning to the end through all the microservices to understand, for example, why requests are slow. Where is the problem? When we're talking about microservices, it's much harder to see these things. I'm sure you've heard it many times. This is old news. So what was happening before there was service meshes, right? So microservices did exist much before there was Kubernetes, and we know that Netflix and Google and all these giants were doing this much before there was any of these buzzwords or things, and but microservices existed, and they presented all of these challenges already back then. So as an example, at least in Java ecosystem, so there were packages of libraries like Spring Cloud or Netflix open source that attended these challenges. So as an example, Spring Cloud and Netflix OSS, it's a group of packages or frameworks that attend all these challenges we are talking about. So they attend problems like service discovery, right? We have many services, many endpoints. We need to know where they lie and what's their IP addresses, for example. So service discovery, we are talking about circuit breaking, okay, or in more general resiliency features where if there is an error in some upstream service, I can deal with it and maybe retry or maybe react with the error, but much faster to enhance experience of the user, and so on and so on. You can see this table. It's a microservice concern. Many of you maybe seen this table, and so it's a microservice concern to how it's attended by Spring Cloud and Netflix OSS. Okay, that's the most important point here. Sorry, the most important point here is that the implementation was in code. Okay, users or developers have to understand this stuff. If you ask yourself, why would a developer wants to understand load balancing or service discovery or circuit breaking? He shouldn't. He should just write its code and be awesome there, right? And we've seen this. We say many, even in the enterprises we are talking about. And I'm not saying, for example, Spring Cloud is not an awesome thing. Spring Cloud is a great framework together with Spring Boot for microservices, and it's very common and popular. But there are things that today, if you're going to build a greenfield application using Spring Boot or Spring Cloud, for example, then you should let go and consider a different approach of how to handle the microservices challenges, right? And we are. It happened to us that in some meetings with customers, we really just caught them in the way that they started to use things like Spring, like a Netflix Eureka, which is for service discovery, okay, and Ribbon, which is doing client load balancing according to the service discovery, and so on. And we told them it's a waste of time, because today we really believe that this is a waste of time, and service meshes can replace this. Right? So what if we could take all of these challenges and fix them or handle or deal with them in a separate layer, which is transparent to application code, right? So a developer can write an HTTP server and basically and just deal with its API and all the stuff related to code, right? Not deal with the resiliency and how the application can deal with upstream services which are unavailable, right? But with distributed tracing or monitoring and so on, right? So this is in fact the base of a service mesh solution, okay? So you would hear about a service mesh or about a service mesh solution. So there is all kinds of definitions for it, but at the end, we have a network of microservices or a distributed application that interact between them, and it can grow. And it's hard to monitor. It's hard to deal with all the challenges we were talking about. And we need things like failure recovery. We want observability. We want to be able to see all the traffic that flows between the segments, between the different segments or the parts of the application, right? Between service A to service B, between service B to service C, and so on. Things about security, okay? With Spring Cloud Security, developers were, for example, were in charge about the code that rotates, for example, certificates served by the web server of the microservice, which is kind of crazy. Why would a developer do this? Okay, so the service mesh can be related as this network of microservices, which can be complex, and the service mesh solution as this independent layer which sits above the compute engine but below your application. Okay, but it also, this solution can be attended as a service mesh. So you can see a service mesh or a service mesh solution, it doesn't matter. And today, service meshes. Just another word about service mesh. From now on, when I say service mesh, I mean the service mesh solution. Okay, I'm not meaning the mesh itself, because mesh is kind of a very complex network and so on. But a good thing to know that the service meshes existed for some time, right? So many of you hear about Istio, and Istio is already in a very mature, very late version. If we are talking about 2.5 years ago, where there was first presented, something like that. But even before Istio, there was service meshes. Okay, and at the beginning they were they had some kind of like a architecture which changed after some time. And today the common architecture of a service mesh is a network of proxies, right? A proxy can be anything. Like it can be Nginx, and it can be HA proxy, and it can be Envoy, and so on. And a control plane that sits on top and controls the configuration of all these proxies. So you kind of have a dumb proxies, right? That they are composing, or they are themselves the data plane. And you have some brain that sits on top that deals with all the configuration and makes things really happen in all the aspects of traffic routing, failure recovery, observability, and so on, all the things we talked about. So if we're talking about containers, because usually today we are doing service mesh with containers, this is the common use case. So we are leveraging this architecture, this very common architecture of service meshes. It's leveraging the sidecar model. Sidecar is just a simple name for a very simple thing, which means if I have my application container, then a sidecar container would be another container that just helps me to do something better in a decoupled way, in a way that it doesn't concern my application code or anything, and the deployment shouldn't be together. Okay. So in a service mesh, the proxies are deployed as this yellow sidecar, and all the traffic in the mesh between the microservices instances, for example, is happening through these proxies, which means that every proxy is taking over on all the inbound and outbound network traffic. All right, and this relates to all of the instances, so they see all the data. all the traffic that flows. And they can do with this traffic many things. They can report metrics on it. They can do smart routing, because now it's a client load balancing. It's not a server load balancing anymore. They maybe can negotiate the TLS session and do encryption without the application even know, right? So then I can get maybe inside like an encryption of the traffic inside Kubernetes, which in most of the cases is not happening, even if the cloud provider has encryption in transit. Okay? And on top of that, we have a service mesh control plane. And what differs between service meshes usually is the control plane. Okay? Because a proxy is a proxy, and usually the proxy is Envoy. Or Envoy, if you hear not an Israeli saying it, it will be Envoy. It's very cool to say Envoy, but I will say Envoy if you let me. And Envoy is a very powerful, high reputation proxy, considered to be very fast with very low footprint, memory, and CPU compared to others. Supports many protocols, is aware of other protocols. It supports all of the features we were talking about. And we will see this in live today. And as said, it mediates all the inbound and outbound traffic for services inside the mesh. Okay, and AWS App Mesh, both AWS App Mesh and Istio, for example, are using Envoy inside the data plane. But there are others, okay? If there are others, like there is an Engine Mesh and Kong Mesh, and they have different proxies. But something important to know about Envoy: Envoy was born into the service meshes world. It was born for it. And the standard protocols, we are not going to get into it much, but there is some mentioning of it. But Envoy supports protocol, which are standard protocol, for example, for discovery and listeners and so on. And what does it mean? It means that the control plane of the service mesh has to provide these endpoints. So both AWS App Mesh and Istio, for example, they have this kind of endpoint. By the way, if anybody has a question, so just text me on the chat, and I'll do my best. I'm checking it once in a while. And it's important to know that Envoy is part of the CNCF we were talking about before. It's part of the landscape, and the community is organized there. And it's open source, of course. So the general thing is said, we have a control plane. Okay, Envoy, what generally happens with this protocol, which I just mentioned, Envoy initiate a long-lived gRPC connection, but the moment it's constructed, the control plane from this point and so on pushes configuration to Envoy. Okay? And the configuration can be everything we mentioned: routing rules, resiliency features, encryption features, how to report stats. Okay, so how to report statistics like, I don't know, traffic volume, traffic statistics like errors, latency, and so on. Okay, this is just the configuration, what to report. And Envoy reports, exposing, and so on. We'll talk about this. But the idea is that the envoys, once they have their configuration, they can take over the traffic from the application in a transparent way. The application doesn't know this traffic is flowing through Envoy, and we can implement all these features, which means developers doesn't need to take care about them anymore. Okay, someone needs to take care about this. This is becoming some kind of a layer which is crucial now, because if this layer is flaking or it's down, we have a problem. We don't have networking anymore. So that's the bad side of it, but I wouldn't call it bad, because I know organizations using it, and they're using it in a very, very good way. So let's talk about AWS App Mesh, because so far we are not talking about it. We were talking about in general. AWS App Mesh, it's the managed service mesh. It means their control plane is dealt by them. They are handling it for you. They are giving you nice features to it. We will see a lot of them today. It provides all the things we said. it serves us as the maintainers or the operators of this mesh a simplified API that is later on translated to Envoy configuration. Okay, so again, in service mesh solutions, we talk to the mesh, or we configure the mesh not in an Envoy configuration way, because Envoy configuration is very complex. It's very hard. And it's about listeners and clusters and so on. We don't really want to do it. We just want to say this service can talk with this service. Between them, I want encryption. I want to route by headers, maybe. I want to have a circuit breaking or some resilience features like retries and so on. But that's it. I don't want to say something more complex than that. Okay. AWS App Mesh lets you span a mesh or just see what we saw in all these nice pictures of the instances and the sidecars. It lets you do this on top of heterogeneous compute infrastructures like EC2, EKS, and ECS. That also includes Fargate. So I can do to implement these features in a seamless way, even if the containers or instances are running on different compute infrastructure, which is very cool. And it enables us very cool features like a gradual migration from ECS to EKS or maybe back. Really cool things. It integrates with many services. We will talk about just a few or a couple today. But for example, for service discovery and distributed tracing, provides easy multi-tenancy. It's something important. We'll talk about this at the end. But I have the ability, a very easy way to just construct more meshes, maybe mesh for staging and mesh for production, for example. Yeah, also runs on AWS Outpost if it's relevant for anybody. So some words about the architecture. I won't go too much into it, but what I want you to take from this, it's the importance of some of the services because they exist in a very similar way, for example, in Istio. Okay, so why am I talking about all the time about Istio? Because most of you know that, or the ones that knows about the existence of service meshes most likely heard about Istio the first. Istio is kind of the Kubernetes of the service meshes world. It's open source. It's very common. It can run natively on Kubernetes and so on. So it's to understand the differences between them. It's important to understand their architecture. But what I want to say is that their architecture is very similar in a way. Okay, and in every service mesh, you will have some of these components. So they're pretty much similar. So if you would want to compare what's better for you, I would start with the control plane and only later the APIs. So we have three main components. We have a front-end server, which I talk to as a DevOps engineer. I tell him all this stuff we said in a very easy way. We will talk about the APIs later on, but the meaning is that I talk with them in a very simplified language. There is another service which takes this simple language and converts it into Envoy configuration, right? And then we have the Envoy management service, which its goal is to distribute, to deal with a very high load and very big number of Envoy proxies, and to make sure that they get their configuration in a very efficient, costly, or I mean like cheap way, and with correctness, right? So it will work perfectly. Why? Because we already understand that if I'm an Envoy and I sit in front of my microservice application container and my configuration is partial because I didn't get it, then the communication will not happen as I want, okay, and not as expected, and that's quite a problem. So that's why I'm focusing on it. By the way, we didn't say, but of course, API server, it scales by the API request, transformer by meshes, and the EMS, which is the horsepower of the control plane. Of course, he scales by the number of envoys. The same goes in Istio. In Istio, the equivalent is something called pilot. And it does the same, more or less. So we said that, so just one word about this, and this is parts where you will want to maybe examine Istio to compare between them, how they deal with a big mesh, all right? Because the first rule about the service mesh solution, if your case is really hundreds or thousands of containers, you need to know that the control plane can deal with it, right? So, because for example, Istio had many problems there at the beginning. So what AWS App Mesh control plane does, it does a combination of change-driven updates and also computes the whole mesh once in a while. So new Envoy can receive the entire configuration of the mesh, but later on, if there are changes, it wants to receive only the changes, right? So that's important, and it distributes, like most of the time, it distributes only what the Envoy cares about. What does it mean cares about? If I am microservice A and I communicate with microservice B and that's it, I just need information about microservice B. I don't want something more than that. And it's a very explicit way how you define it in AWS App Mesh, and we will see it. And it's more opinionated than Istio, if you would compare. It's important to know that the Envoy container needs permissions, IAM permissions, in order to receive configuration. So it means that the Envoy has to be authorized, authenticated and authorized to AWS. So let's talk about some configuration concepts, which is the simple language I was talking about. So we have something called virtual node, which I call it a workload. It can be a group. As I see it, it's any group of instances of a service which are exactly the same. It means the same version as well. Okay, so if I have two versions of the same service, it's two virtual nodes. Okay, so at the end, it's the workload itself, and it's the two edges of a network communication, like the source and the destination. Between them sits something called a virtual service, which you can look at them as a Kubernetes deployment and a Kubernetes service. It's an abstraction of a real service that can be composed from one virtual node or more. Okay. And I can put something between these multiple virtual nodes and the virtual service, which is called a router. And this router let me implement all these advanced features we were talking about. Okay, in a router, I can say things, not all of them, okay, but most of the things about traffic routing and retry strategy, okay, I can implement through the routes. Things like TLS encryption, we are doing it on the virtual node level. We will see it later. Okay, but the idea is that these are the basic concepts of AWS App Mesh. It's very simplified. I like it very much personally because I come from Istio world. Most of the time I'm implementing Istio. And App Mesh is something we are new in implementation, but we know Istio very good, and we like it that it's simple. Okay, I still don't have the whole variety I have from Istio, but it makes it simpler. And it's of course important to know that these are not some nodes in the network path. These are just API resources that later on App Mesh takes them and makes them a flat Envoy configuration and delivers it to the Envoy. Okay, again, if anybody has questions, so please write in chat. Because if something is not clear, I would like to clear that out. So before we go on, I just want to say something about our demo app, which will, through it, will present some of the features. So we're taking also the color away to do the things in the service mesh. You will maybe see some other stuff, but we built something of our own, which we think is cooler. So we have microservice, which is called dashboard. It's a front-end server. It's a Node.js Express web server, and we have a backend, two backend versions, two versions of a backend microservice, which just delivers color. Okay, so if we connect it to the App Mesh language, then we have a dashboard. The dashboard is the front end. We have a dashboard virtual node. It communicates with the color virtual service, which has its own FQDN or resolvable address. And via virtual router, we are going to show all the features of routing and resiliency mainly. Okay, and in this demo, we are running on EKS. We will talk more about the implementation with EKS, but I will show shortly, because not all of us today are AWS users. I will show shortly how to the dialog where you configure a ECS task, specifically Fargate, with the mesh integration. So the application itself, every time I refresh it, I'm not a genius in CSS and stuff, so that's the best I could do. Every time I refresh this application, we have some 120 more or less divs or these boxes, and every box is an AJAX call to the dashboard, which forwards do a subsequent request to the color service. And that's why if I have a virtual router, in this case, that splits, let's say 50-50 traffic between the virtual nodes, then I get more or less half of this color and half of this color. And then I do things as I don't know, delete service and see how the mesh is dealing with them and so on. And this will all be reflected in this application. After I will upload everything to CloudZone GitHub, and I will share it with you. It's not there yet, but it's a very simple way to demonstrate the capabilities. So let's talk about the integration with EKS, and then we could be able to really show about the implementation, because as I said, the focus is mainly integrating EKS. For no, I'm sorry. First of all, I will just go over. I will go over the screens more or less how they look like, and I will show how this application how it's configured there. So we'll go. So imagine. So it doesn't matter. We didn't talk yet about integration with Kubernetes, but let's just connect it now with the dots with the language we were talking about. So I have a mesh here. It's called CloudZone staging. Most likely in the real world, it would be the mesh for the staging environment, which could be maybe a mix of ECS and Kubernetes. I mean EKS, or maybe it would be only one namespace on EKS or multiple namespace. It doesn't matter. And that's all I have here. I have virtual nodes, which I have. Let's ignore the ECS one. I have the dashboard, and I have two color staging, two colors virtual nodes, each for one for each color. Then we have two virtual services. One is a dashboard, which sits on top of the virtual node of the dashboard. Then we have the color virtual service. And if I go inside, I can see, sorry, I can see that it's using a virtual router, and these are the routes. Okay, so I have all kinds of routes. I have a route for resiliency, for example. Through it, we will show how the retry mechanism works. I can route, for example, by headers. Okay, I have a route that says very simple thing. Every time there is a header of this key and this value, okay, route everything to color green. Okay, so Let's see it. Yeah, we'll open the developer tools. It will be quiet. I hope you see it okay. Because that's why I'm sorry it's not frontal, but it should be fine. So if we will look at the network, I can see that upon the load, all the 100 and something requests are going up parallelly. And now I get more or less 50-50 distribution. And that's because if I will go to the default route, where am I? I will go, I'll try to make it bigger. I hope it's good enough. If it's small, just write me. So if I will look at the routes, first of all, this is the router. So I will go to the color router. I'll go to default, which is no matching whatsoever. I can see that I have a 50-50 distribution between these two virtual nodes. Okay. Let's look at another route, for example, about this one. Go inside. So this says that, again, what we said at first, if I have this header, okay, then just get me the green, 100% green. So I will go to this cool Chrome extension that sets headers. I will say CLDZ user is me. Then I should receive only green. Okay. And this is not related to the number of replicas of the pods in Kubernetes. We will look in a second about Kubernetes itself. Okay, but I get now just green. Okay, so we'll just go and see what we can do with a route just to cover up. Okay, because App Mesh is, I would say, still relatively new, and what you see currently is what you get. That's the current state of the features. Like I mean, in the configuration for the App Mesh. I'm not talking yet about the integrations, which is cool, but you can match about any prefix with any method, with any scheme. Okay, so you have conditions how to match this route to anything. Of course, there is a priority, whose match first takes the implementation of this traffic. I can define headers. Okay. In this case, it's important to understand that inside the code, I propagated the headers to the dependent microservice. Okay, I have to do this in code. Okay, because the Envoy doesn't do it for you. We will see it. And then I have the section of retry policy. Retry policy just say, for example, the request will go from me, from the dashboard service, right? The dashboard service will send it to one of the color virtual nodes, and let's say one of the colors pods of the target version just died. Okay, so I can so Envoy can retry this. Okay, in a transparent way. In what I mean is the user or the application doesn't know it was retried. It was just some longer request. Okay. But what does it really mean, longer request? Inside Kubernetes, if one pod was deleted or it was running on was just preempted, or I don't know, I'm not dealing with preemption good enough, then it will be just another 2 milliseconds. Okay, so it's worth it. It gives me great resiliency for a microservices application. The ones who know what a circuit breaker is, I'm not going into this, but this is not a circuit breaker. Circuit breaking features, which Envoy supports, but App Mesh yet doesn't support, it's in the roadmap. Okay, so for resiliency, what we have now is just retry policy. Okay, and this matches, and once I'm matching all of this, and I have these resiliency features, we skip the routing, but I can add the routing and choose the virtual nodes and the amount of traffic. Okay, so again, we can match by headers, by path, by verts, and we can choose how to route it to who. And specifically, in this route, if it's matched, the resiliency applies only to this route. Okay, So let's demonstrate about the resiliency now. So again, I will go back. I will remove this. Refresh again. I should get it again. And we didn't mention, but of course, this helps me with the canary deployments, A/B testing, and all these advanced deployment strategies. That's clear if we're talking about the routing, but also about the resiliency. So let's take a look about our Kubernetes cluster running on EKS. Let's look about the namespaces, for example. So we are running our applications in the staging namespace, and in Kubernetes, all the components that relates to the app mesh, we didn't talk about them. We will talk about them in a second. They lives inside the app mesh system. Okay, let's look at them later. So I'm in the staging currently. No, I'm not in the staging. So I have 5 green pods, but for example, let's scale the green just so we see that all this ratio of the traffic routing it has nothing to do with the numbers of replicas really, because in Kubernetes alone, if you want to do this ratio, you have to scale. You have to configure a service which will have a selector to 2 deployments or pause a running update in the middle, and just take care that the instances will reflect the ratio of the traffic. But it's not the case with a service mesh, of course. So we have a 2 and a 2 of the green and orange, and again, still, I should get a 50-50 distribution. The reason I'm scaling it back to 5 is because I want to kill some pods, and I still want some pods which are alive, right? Because these pods in the real world, 5 pods will not be on the same host unless there is some affinity. But come on. So the idea is, if, for example, to have the scenario where I'm on an instance, I have some pods on an instance which is just crashed, panicked, terminated by accident, I don't know. Okay, it's important to say that these applications, in a purpose, they are not. The code is not dealing with graceful shutdown. So if Kubernetes sends them some kind of a sick term where they are deleted or anything, they just die. The web server is killing the request which is still handles, and the downstream service would have a 500 error. Yeah. Okay. Okay. Cool. So let's kill some pods. We take a look specifically about this command. We are going to kill 2 pods of the green version, all right? And then I will immediately refresh and we'll see what's happening. So these black squares are requests, AJAX requests that the dashboard received, and you try to send them to the green microservice. But at that moment, this pod died, right? It can be that his request was there, or the Envoy still had in the cache the endpoint that is no longer there. It doesn't matter. If we will refresh, it's already done. It's already recovered. Okay, which means the Envoy already got the new information from the control plane about the new pods, or to understand that the unhealthy pods, they're ejected. They don't no longer, it should no longer forward traffic to. Okay. Let's kill maybe 3. It will be more destructive. See it again, how it behaves. I really hope you see it as good as me because the application is very smooth. Okay. So I will check the log of some of the dashboards or pods. I would see the error that Envoy sent to the upstream. It's an error that is coming from Envoy. What? Okay. Dash. Okay. So I can see that sometimes I got the color from the color controller, but sometimes I get upstream connect error, which means this is error that comes from Envoy. Okay, and that's why it doesn't get a color and the div is not being set with its style. Okay, let's see if it's recovered. Yeah. Let's do the same again, and then I will set in a header that matches a route in App Mesh that is doing a retry policy, some resiliency features. Okay, and then we expect to see some squares that takes a bit more time, maybe really just a fraction, but they are all green. So I will delete this again. I will see the error ears. They're still here. It takes time. Then I will set an header saying CLDZ retry true, and I will refresh again. Then I see some stacking divs, but at the end, it's all green. You know, just one node. Maybe it was too harsh. Okay, but if I will now remove this header, I will see that the error still exists. Now without the resiliency, I will still have errors. Okay, so it's very powerful. It's very transparent to the user. Okay, so that was some demonstration of the really what App Mesh has to give you in traffic routing and in resiliency. What we are missing still is some things about observability and security. By the way, okay, let's return to just user for now that gets all the green. All right, cool. So how will all of this happen? So let's talk about the integration with EKS because as we see it, it's currently the most relevant, but we'll see some about ECS. So pods are getting instantiated inside Kubernetes. Okay. And I want to be able to deliver to Envoy that the app mesh will be able to deliver Envoy with information, for example, on the endpoints, right? We're talking about service discovery because what's really happening now when Envoy is doing the routing, we are really bypassing the native routing of Kubernetes, which is IP tables, right? So IP tables, which is part of kubeproxy, he knows everything about the endpoints, right? Because he's talking to the endpoint controller, which sits inside the control plane of Kubernetes. So all nice and good. A new pod is added to the cluster. It's added to the endpoint controller. If nobody knows what's endpoint controller or what's endpoint in Kubernetes. So an endpoint is just a combination of the IP and port of a pod which passed all of the liveness and readiness checks and so on. It's a healthy endpoint that I can send traffic to. This is how kubeproxy updates itself with all the endpoints in the cluster so you can route traffic to. But when Envoy is doing this routing, he's not aware of this, right? Maybe they could be integrating it with Kubernetes or maybe with some other stuff. Istio, for example, is doing the same. He's learning about all the endpoints from Kubernetes. He's asking Kubernetes about new pods. He's watching for pods, just like kubectl watch, and that's how Istio works. But Envoy, but in App Mesh, this is different. Why? Because I want to be able to discover endpoints from maybe from ECS, maybe from EC2, and so on. So For the service discovery integration, we are integrating. AWS App Mesh has two options. You can integrate with a cloud map. Cloud map we'll talk about it shortly, but cloud map is AWS managed service for service discovery. You can think about it like a managed console, like HashiCorp console or Zookeeper, but it has rich features. Okay, and that's what we will demonstrate today. But still, I need something that updates it. All right. So in App Mesh, in the integration with AWS Cloud Map, all the service discovery, the Envoy is all the information about endpoint. Envoy receives from Cloud Map. Okay, but when a new pod arrives, I need to be able to update this information in Cloud Map. So for that, AWS developed two open source components, which is a must when you're running when you want to run inside App Mesh in Kubernetes, which is App Mesh Inject and App Mesh Controller. App Mesh Inject is very simple service. All it does is injecting Envoy inside your sidecar. Okay, so I won't be needing to every time I deploy some deployments to the mesh, I need to really give the spec of the Envoy container inside the deployment YAML file, for example. So I send a regular deployment, and the mesh inject just injects the Envoy spec inside with the configuration that it knows it needs to put there. Okay, so that's one thing about just having the Envoy inside. The more sophisticated component is the App Mesh Controller, which is doing several stuff. The basic thing before the service discovery, I just skipped it. So before that, it lets me define virtual nodes and virtual services and the routes in a declarative way inside Kubernetes. Okay, so this is done with CRDs or custom resource definitions of Kubernetes. But if I'm looking at about the App Mesh, I don't want to go and create everything, right? It's really cumbersome to create all of these things, the node and the service, and I don't want to do this. All right, so Kubernetes, the App Mesh Controller, enables me to define these here. All right. So what you saw in the console of the AWS App Mesh is just a sync of what you see here. All right. The controller watches this stuff and creates it in the App Mesh. So if I will look, where is my coder virtual? It's weird. This is it here. Okay. Anyway, we'll check it later. Okay, so it allows me to sync all of this into App Mesh. And the second thing is doing is watching the pods, just like Istio would do, all right, or kubeproxy would do. And every time you see the new pods, you already know with this pod to what virtual node it belongs in the App Mesh, right? Because this configuration was done. I just showed you this, and it updates Cloud Map with the new instances, right? So new pods arrive all the time, and immediately they appear on Cloud Map. Okay, and EMS learns it and distributes it in a very high scale to all the envoys, which we covered, right? So in this way, we can keep the dynamic manner of Kubernetes of pods getting lost and destroyed, and new pods arrives, and still be able to preserve all the correctness of the mesh. If we will look if we will move for the App Mesh namespace, we would see this. Okay, this of course was just a second to see the version of Helm. Okay, so I have two charts, which are just these components. Okay, so I want to show you about this, how is it really connected with the community. So if I will go to the Cube Apps Hub, I will look for App Mesh. I will see them here. Okay, delivered by AWS. The App Mesh controller and App Mesh inject. These are the must. Okay, we have several other things here. If we have time and someone will ask, we will cover them. But these are the main, are the must-have for you to run App Mesh injected envoys inside Kubernetes. Okay, this is independent to EKS. It can run on Kubernetes. It doesn't really matter. So what I just wanted to say is, if we look about the logs of the, okay, we can see that he's syncing pods and their IPs, right? This is an instance going into Cloud Map. This is how the spec of an endpoint look in the service discovery of Cloud Map. Okay, if you don't need really to understand it now, it doesn't matter. The focus is not Cloud Map, but is really watching for pods and syncing them to Cloud Map. Okay. Okay. So the envoy learns about the new pods. This happens pretty quickly. If pods are deleted, that's why we have the retry policies, which we just saw. So when I imagine all of this together, I imagine a scenario where I can run in production on spot instances without being worried too much about preemption or about nodes termination, because I know that I have a resiliency mechanism which works very good. There is a slide on how the injection works. I'm going to skip now because we don't have time, but you will have this slides, and you can go to this link. I figured out we won't have time. So before we go to some capabilities or use cases where we can do stuff, let's just watch for a cloud map, for example. Okay, so if I will look on the virtual node, about its definition, I will go to inside of it. I will see that I can tell him in the service discovery mechanism, cloud map, and I can tell him to what namespace it belongs and what is the service name. It's not by chance that the dashboard microservice connects when he wants to connect to one of the virtual nodes. He's just doing HTTP to color.appmesh.demo.local. Okay, this is something that makes it happening. That this is a friendly name which is created through Cloud Map. Okay, this of course is reflected here. Yeah, I can see the service discovery type, Cloud Map, what namespace, what color. And if I will go to Cloud Map, I can see this namespace here. And I can see the color in the dashboard services. If I will go inside, I will see the endpoints. All right, these are the IP addresses of the pods. Okay, we have, for the green, we have quite a lot. Sorry, I will be more accurate. Both the green and the orange virtual nodes, they both are registered to the same service. This is important, right? Because when I attend to the service, I know that maybe on the back and in the backend there are several versions. There is a canary there is stuff, and these versions are virtual nodes on themselves. So it's important that the virtual nodes, they are registering to the same service discovery service. All right. So here there is pods, both of the orange, both of the green. All right. So I will look about the spec of the orange. Then I will see that it registers to the same virtual service. Okay. And under the dashboard, we have two IP addresses, which is the dashboard pods. Okay, and of course, if it's not clear, in every pod we have 3 containers. About the third container we will talk later, but we have 2 containers inside the application container and the Envoy container. Okay, but the deployment spec it's just 1 container. The injection is adding the rest. Okay. I will have to make sure that people are here because I don't see who is joined and nobody writes, so I will just make sure somehow. Okay, I can see. Okay, so 2, we lost 2. Oh, that's a good number. Okay. So let's go back to the slides. How much time do we have? We have 30 minutes. I'll hope to make it fast. So just some use cases. I can make a cross-cluster mesh in a very easy way, right? Because the service discovery service is just on the top. It's above. Okay, it's not living inside a specific Kubernetes cluster. In Istio, it's more difficult to do. Okay, because the cross-cluster scenario in Istio, it's more difficult. Maybe some people much more difficult. Here, it's just a clone. I can just put the mesh controller, both of them, and in each one define the virtual nodes I want, and things will work, right? Because they have the same available discovery service and so on. The same goes with Fargate. Okay, so on the left I have Kubernetes cluster. On the left I have Fargate tasks. The tasks. So if in Kubernetes I have admission controller that injects Envoy inside, in Fargate I need to do something by myself. Of course, the API supports it. I will just show it. I said I will show it shortly. Okay, because it's not relevant for everybody. But if I will go to so, by the way, I have a service in CloudMap, an ECS one, and I have the tasks here. They're registered here. So how does this happen? And by the way, once it's here, there is a service in CloudMap, which ECS Fargate populated it. That's it. An Envoy from Kubernetes knows this just as if they were pods. It doesn't matter for it. It learns the IP from inside the definition. That's it. And it can do all the traffic routing we were talking about and all of the things on ECS in a very transparent way, right? So if I will look at about CS, I have a Fargate cluster here. And I have this virtual node here. Again, a virtual node would be a Fargate service, not a task. Just as we have a virtual node, which is a Kubernetes deployment, and it has multiple instances, I want an ECS service to have multiple tasks in the same definition. If I will go to the definition, maybe I can already see here, but I rather go to the, yeah. So first of all, we can see the integration with the namespace of CloudMap. Okay, but I want to show you also how you put inside an Envoy, because it's different. I will go to the task definition. I will just do create new revision so you can see the dialog. So if I will go down, so first of all, I have a Envoy here, but I didn't add it by myself with add container, and just click enable App Mesh Integration. Okay, what I would do here, this is populated for you, the Envoy image. It's important to know to understand that there is a flavor of Envoy image which is supplied by AWS. It's specific to their needs, for example, for IAM authorization and so on. Okay, so you cannot just use the open source, I don't know, the main one, the official one. So you need to use their list. You can see the list of images per region. You can use this for all of the regions except China, I think. But it's important to know that the Envoy is a different build. Okay, you choose the mesh and you choose the virtual node. Okay, in this case, I had to create a virtual node before. Unlike Kubernetes, which I have CRDs and a kind of an operator, the controller that is doing this for me, here I need to create a virtual nodes upfront. And once I do this, all the rest, this in combination of the service discovery of the task of that service, it pretty much ends with the same results and products as we just saw for the Kubernetes stuff. So it's virtual nodes that I created, a virtual service, and a cloud map namespace. I'm in cloud map service. Okay, and the discovery. And once I for example, will scale the service, the ECS service, of course, the endpoints will be added to the cloud map service, and Envoy could find these new endpoints. So I can, in the same way, easily I can just replace here Fargate with regular ECS or just Elastic Compute. So we covered the integration with AWS Cloud Map. But let's talk about now the integration with X-Ray. So I have a slide about service discovery. So just let's see if we missed anything. So before we are talking about X-Ray. So again, we said I have an Envoy, and I need to run a request to backend microservice, and I need to Envoy needs to load balance with all these sophisticated features on some endpoints. So how do I know the endpoints? I know it from Cloud Map. Okay, App Mesh also supports. You don't have to use Cloud Map. App Mesh also supports DNS mode. I'll talk about it shortly. So again, I think we covered here everything. It's important to know that Cloud Map it's AWS managed solution for service discovery. It supports non-IP instances like S3 buckets and DynamoDB, so I can really discover DynamoDB tables with Cloud Map. I know some of the participants are using these features, which is nice to know. The thing is, I'm not going to cover it. We don't have much time, but there is something called attribute filtering, which this is the base of how Envoy knows to distinguish between endpoints of orange and endpoints of green, because remember we said they are registered to the same Cloud Map service. So what does it mean is that if I'm not using Cloud Map service, I have some limited configuration that I can use, let's say, or limited features of the App Mesh. So just in general, for example, ECS before, what is really changing here, right? Because to the ones who know, ECS, service discovery, was until now, or still is in many places, server-side discovery, which means a load balancer. I have for each service, I have an internal load balancer maybe, and that's how another service goes to this service. It just goes to the load balancers, and the load balancers proxies all the connections. And this can be nice, but we know that it adds latency, and in some cases this is not good. But regardless, many customers want to be able to use client load balancing. I know customers that are using still a Spring Ribbon or Ribbon and Eureka for client load balancing inside Kubernetes. They don't even want to have the server-side Kubernetes of the regular services in Kubernetes. So some customers really demand it. And once we are using Envoy or App Mesh, we no longer need for internal services, like internal microservices, to be exposed with a load balancer. I don't need it anymore because Envoy is doing client load balancing on them, even if they're sitting on ECS. So this removes the need to use load balancers with ECS. Okay, if you're using App Mesh with ECS, the only ones who need to be exposed with the load balancers is a public-facing or user-facing services. Yeah. It also integrates with a console and external DNS. So external DNS is this component that syncs ingresses to not just ingresses, but most commonly ingresses to Route 53, and load balancers to Route 53, like services with type load balancers in Kubernetes, and also with Tetrate. Tetrate is an enterprise grade service mesh, which is based on Istio, where you can buy their product and run it on even on EKS. So they have a cooperation with AWS, and they build cool integration with CloudMap. So know that it exists. And we said that we can integrate with a CloudMap for service discovery or DNS. You have it on the slides if it's interesting for you, how it really works with DNS. But I don't see it as a good option. I would go for CloudMap most definitely. So we've seen now, I think, most of the things. Let's talk about observability, or in this case, distributed tracing integration. So what is distributed tracing, right? So we saw a slide on it on the beginning. So we have many microservices, and for each microservice, we have many instances, and I send a request. I want to know, just a second. So sorry for this. So let's say I have traffic, I have requested flows. So first, I want to know in general the behavior of the traffic, how much traffic between each service, between each of these segments, and I want to be able to trace specific requests and see how it spend time in each microservice, and to see the latency and the errors, and maybe even to do it in application level, right? Not just network level or HTTP level, okay? Not just the latency and the request and the response status and so on, or the path. I just maybe want to know even the application-wise, okay? Distributed tracing enables us to do it. Okay, so I'm talking about distributed tracing in general. Very commonly exists, like I guess most of you or majority of you know Zipkin, heard Zipkin, heard what is the open tracing standard. So there are many tools and standards in this world for tracing. In Istio, it's based on open tracing, based on Zipkin or Jagger, which is Zipkin compatible. But in AWS App Mesh, you can do not just this, all right? So Zipkin is supported. And if I will go just a second for the hub, I have here AWS App Mesh Jagger, delivered by AWS. This is if I'm going to working with the distributed tracing in App Mesh, but with open tracing, okay? So it means that the envoys will report metrics. We will talk about this in a second, what is this kind of metrics and how it works, but the envoys in the AWS App Mesh can really report open tracing based headers, for example. Okay, so it's still supported. It's not that AWS makes you use X-Ray. Okay, but X-Ray is something else. So X-Ray is managed service by AWS for tracing. Gives you the agent that ingests all the traces or segments. Okay, so I will first show this, and then we'll talk about it. So a trace is a flow of all the requests spanning all these components or microservices. Okay, but X-Ray gives us the possibility to show in the flow things which are not just my application or not my code. Okay, so it's also no API gateway and Lambda and DynamoDB, and it sees actions with DynamoDB. The SDK of X-Ray, if you use it in your code, you can really trace what your application is doing API-wise with DynamoDB and see the latency of each of these stuff. It's very cool, but I'm not showing it because I don't have it. But it's important to understand that X-Ray receives something called segments from all of these components. Okay. In open tracing, it's called spans. Okay, but it works kind of the same, but like AWS has their own headers for this. And at the end, this service like X-Ray, you can take all of these segments. They know they're related to each other because there is some parent stuff and so on. I'm not going into this. But at the end, you can really draw you a specific request, like a single request, end-to-end. So it integrates with API Gateway, Lambda. It's important to know that any application load balancers in AWS generates these headers by default. So if I'm exposing my dashboard service with an application load balancers, like the span will consider the time from the load balancer to the dashboard container. It's important. And you have SDK for everything, like most of the things. So how it will look like? So I have a possibility to, which time do we have? Okay, we still have time. So the app inject, app mesh inject. Sorry, not this. App mesh inject. I can tell him if to enable tracing or not. And why it's in the injector, the app mesh injection component, it's because it injects the Envoy that it injects into your pod, how to behave, how to generate tracing information. Okay, and the default provider is X-Ray, but I can go to Jagger. Okay, so I can still work with Jagger, which is, I know, important for many people. But still, I would say I would recommend for customers working with AWS like application, like consuming in their application AWS services or resources like DynamoDB and S3 and so on. It's very powerful to use the X-Ray because he's aware of all of this. And open tracing is not. And also you have Datadog. So I have installed the app inject. When I did the Helm install, when I installed the chart, I said enable, and that's it. So I have X-Ray. What is causing is that in addition to inject the Envoy, it would also inject an X-Ray daemon that listens for spans locally on port 2000, I think, both from the Envoy and both from your application. Okay, because when we are talking about tracing, you do want to instrument your application, which means use the SDK inside. Okay, in many times it's very easy. It can be just 1 or 2 lines. Okay, with I don't know, with a Spring Sleuth, which is if you're developing microservices with Spring Cloud. So Spring Cloud Sleuth is doing just the same. Is doing the same. Yeah, it's propagating headers and so on. But when you're working with X-Ray and Kubernetes, so it can just inject the X-Ray daemon inside. So that's why I have 3 containers in each pod. And we have the Gopher from Jagger here. And this is Jagger. To remind you that it's still supported, just like in Istio, for example, right? Because Istio can come also out of the box with Jagger. But if I work with Jagger, then I would just have 2 containers, and Envoy would generate open tracing headers, the headers of the open tracing standard. Okay, but we are not covering this now. We are talking about X-Ray. So let's see, it's in action. All right, so I will just let's refresh both versions, so it will be interesting. So I will remove the header. Give him another one. So the ones who is using Istio, this might look for them like not Jagger, but most likely like Kiali visualization. So X-Ray really gives me both. It gives me the overall traffic statistics, like how much the average from this segment to that segment, right? How many transactions per minute. I should see also a line goes to the there. I guess I will see it in a few seconds because I have just also the orange and also the yes, so it's here. Okay. We're not talking a lot on X-ray. I just want to say that you can visualize more or less the latency and also understand from that the footprint, the latency that Envoy really adds is very minimal. What you see here actually is the app mesh proxies themselves. So I can see the volume of the traffic. We are not yet talking about traces, okay? We are not talking here about a single end-to-end flow of a trace of a request. We're talking about the overall let's just do 5 minutes. Okay. So what I can see here, we also got some errors. I can see that the segment, the latency of the segment to the proxy. If you can see here, very good. It says app mesh proxy. It's the type. Okay, when you are reporting to X-ray, you can tell the type. It can be ECS task. It can be API gateway. It can be many things. And then I can see it moves from the Envoy to the container itself, to the application container. Okay, so I can really understand also, okay, what is the footprint of like latency-wise of the Envoy? And I can see, of course, the directions and so on. And in each segment, I can see the latency. So I can see that 60% of this segment from the dashboard, from the proxy to the proxy. So, okay, just to make clear, the traffic goes first to the proxy of dashboard. Inside the pod of dashboard, it goes to the container of the dashboard. It goes back. Why? Because dashboard initiates a request to one of the virtual nodes of the color controller. Envoy then have really both traffic to the Envoy of the green and the orange, right? And then on their turn, of course, have their own traffic to color green. So yes, makes it a bit more difficult to understand once you are working with App Mesh and with a service mesh, because this can be used, X-ray or tracing can be used regardless of App Mesh. I can just use it with microservices without, okay? But then I lose everything that we saw today. So it makes it a bit more difficult, but it's still important to know the role the Envoy is playing here. And if I will go to traces, I can start to see specific trace. So if I will okay, what I'm interested about is the slash API, okay? Because the slash API, this is the load balancer, and the slash API is the Ajax call itself. So I can see all the traces, okay? And these traces are specific requests end to end, right? So I can see their response time and so on. But what's important is I can see the specific request, how much time it's spent in each component, okay? And I have this specific nice stuff. So if you can see here, we have really one request in each container. The Envoy of the dashboard is doing 2 requests, one to the container and one to the upstream service. It's clear. I know that this will be this can be very confusing now. We don't need to get into details here. But people who saw Jagger or Open Tracing or Zipkin and so on, this screen, this bottom part, it's very familiar. It's very familiar for you, I'm sure. Okay, so what we understand from here is that also Envoy containers, they generate data. What does it mean? It means that maybe I don't want to know the resolution of the Envoy to the container is not so important to me, and I don't want to really instrument my code with SDK of X-Ray or Zipkin, because I instrumented the code. If we will look at the code, I have here the SDK of X-Ray for Node.js, and specifically X-Ray SDK Express, which is doing a lot of magic by itself. I don't need to do many things. And the Color service, which is a Go application, also has the X-Ray SDK. I will share all the code with you. Don't be disappointed because I'm not that good a developer today. Okay, but in order to get this really connectivity, to understand all the flow of the request, I have to instrument the code. But if I wouldn't do this, I would still get this. Right? I would still get this. And what I say now, it's not also for X-Ray, it's also for Istio. Okay, in Istio, it would just split into two services. It will be the tracing in Jagger, so you will stop using Jagger. But this you will see in Grafana, right? With Prometheus metrics. So I don't really have to instrument my code. If I don't instrument my code, I lose the application level tracing segments. Okay? But I can still see all the volume of the traffic, the latency, the stuff, which is really, it's 80% of the valuable data. So just know that you can let go if it's really hard for you to instrument your services. So that's the only thing that is not really transparent to the code, but can be still transparent to the code if you let go this. But this screen, you get it, both here, both in Istio, without instrumenting your code. Right? Why? Because Envoy itself is generating segments and it's sending it to X-Ray. Or to be more precisely, the daemon of the X-Ray sends it to all the traces from Envoy to X-Ray. Let's talk about, we have 15 minutes. It's long enough to finish. We have also the possibility to have encryption between the envoys, to have a session, TLS session. So in this use case, in Istio, it's a bit different. They have this feature, but it's much more rich features, and it comes with authentication. I will talk about it at the end. So what does it mean really is, it means that I can have my own microservice server, which is naive, which is good. I don't need to handle certificates. I don't need to serve them. I don't need to rotate them. Envoy is doing it for me with a control plane. It can have certificates, and two envoys can initiate or negotiate a session between them, a TLS session, and encrypt the traffic. Okay, if it's inside the Kubernetes or it's cross compute platforms, but they are doing this negotiation on the favor of the application. The application is not aware of this. If I will be microservice on the left and I will want to reach the microservice on the other side, I will just curl or do a HTTP request, but the request will go encrypted. Okay, and then it means I can decouple it. Of course, I can decouple it from code, which is amazing, but also the rotation mechanisms and all this stuff I can receive from the control plane. It's important to know that TLS in AWS App Mesh is working with, it can work with the certificate manager or your own certificates. It's in preview currently. It does not exist in the console I was working with. I will talk about the App Mesh beta channel to let you understand how you can use features in preview. But it's something very cool that the App Mesh team is doing for you, is really giving you an endpoint, a real App Mesh endpoint to work with and experience the new features or comment on them, and they are really care about this, and they're treating them. So what is it not, but does exist in Istio? It's not a mechanism for authentication. Okay, so in Istio, these certificates are also used for authentication, and their common name in the certificate contains, in Istio I'm talking about, contains a SPIFFE identity. SPIFFE, you can look it up. It's an identity framework for cloud-native applications, and Istio is working for that. In Istio, what I can get is not just an encrypted TLS channel like this, which is amazing. I can also authenticate. They authenticate each other before, in order for this to happen. And once they're authenticated, Istio provides authorization features, right? Which a service can be blocked when accessing another service on a specific path, on a specific verb, and so on. Okay, so it exists in in Istio, and for App Mesh, it's in the roadmap. And the roadmap. So the roadmap, it's a very cool thing. You can watch all the features that are waiting in the roadmap. Okay, so I will look. So you have researching, you have working on, and so on. If you will see, you have here a section which is meeting available in preview channel. This means you can consume it in the London region, right? And you have AWS commands, which has this, you can have this CLI flavor with all these commands. So in order for you to do the TLS virtual node, okay, you can do this in London now. So it's a very cool thing. I didn't see this for many, I don't think this exists for other AWS services where the team really provides you an endpoint with where you can comment and onboard this channel and be part of this. It's very cool. We are just doing it. I suggest that if you're into it, and I know some people here are into onboarding App Mesh on AWS, so I would recommend you to do this. It's very good to be part of this. Let's have a 5 minutes comparison with Istio. I will try to be brief. Whoever doesn't tell him too much because there's something on Istio that doesn't exist on AppMesh, just ignore it. That's fine. If you're going to AppMesh, just keep with AppMesh. But some people here to hear about the comparison with Istio. So Istio, it's a service mesh by Google, and like originally by Google, Lyft, and IBM. Today, it's really has a contribution for other vendors, and it's as I said, it's just Kubernetes of the service mesh world. So it means that there are many contributions you can contribute and so on. May 2017 was the first not production version. The 1.0 was the first GA. It had many problems. We experienced this. It was a lot of hell. We opened many bugs, many fundamental bugs. It was even after 1.0, it was not doing so good. But I would say that today it's much more like the latest, much of the features between 1.0 to 1.4 are focused on stability and about reducing the footprint of the envoys in the mesh. So at the beginning, they were talking about 10 latency or above 10 milliseconds latency per envoy, which is crazy. So it's not there already. They reduced a lot of the stuff which is unneeded, and by stuff I mean like because it's still envoy, it's the same envoy. I'm talking about metrics that it's exposes and so on. But as you saw in App Mesh, at least for my tests, the requests. Okay, my requests are really small. And the configuration which Envoy needs to look in the request itself, it's pretty low, but you saw it was one millisecond, so it's like that. But the same as App Mesh, it leverages the sidecar model. As I said, it has a control plane which is kind of similar to the App Mesh control plane. But as I said, it leverages much more of Envoy features than App Mesh. Okay, because at the end, the features about, if we're talking about the core features of traffic routing, security, observability, and so on, they are all possible if Envoy makes it possible. Okay, so Envoy is like the bottom blocker for everything. What doesn't exist on Envoy doesn't exist. Okay, so it's all about how much of the control plane is letting you configure Envoy configuration at the end. Okay, so Istio has much more rich configurations kinds, really. So I would see it as a good thing, but it can be very overwhelming. And I'm talking about from experience, not of mine, of other people. It can be very overwhelming, and that's what I like about AWS App Mesh in this context. So some comparison, and this is the last slide. Whoever wants to stay for a Q&A, I will stay 10 minutes. Okay. So let's not go through about all of them. Let's just clear what is important in my opinion. So multi-tenancy, I've said, in App Mesh, it's real and easy. In Istio, it's soft, which means it's kind of you need to instantiate a whole control plane for each mesh, which is kind of crazy. I think it's still the situation. Like I know 2 versions ago it was still like that. And this is something which is very cool about the App Mesh, which really they give you really easy multi-tenancy. What else? Traffic mirroring does not exist on App Mesh, and it's supported in Istio. So imagine I could just mirror all of the traffic, the real traffic from production to some staging cluster or staging mesh. It's very cool. Proxy authorization. So we said the proxy has to have an IAM role, even if it's attached to the node, the Kubernetes node the code is running on, or to leverage the OpenID Connect integration, which is amazing in EKS with AWS, which is great, and then the service account of the pod of where the Envoy is injected can assume the role to do all the stuff. It's very cool. With Istio, it's my fault. I should have filled it. I don't remember. I think from what I checked, it just validates the certificate of the pilot. Protocols in Istio. So Istio is aware of much more protocols, and it can give metrics on MySQL queries, Mongo queries, Rails queries. We said it's giving you mutual TLS authentication, which AppMesh doesn't. So it gives you authorization, really like a kind of application gateway features. Istio is zone-aware routing. This is very important. Zone-aware routing, it means that if I'm an envoy inside a pod in a node that is in the one availability zone, and I want to send a request to microservice B, which has endpoints all over, Envoy in Istio will first send traffic to endpoints in its own zone. So you can mitigate costs of inter-availability zone traffic. This is not happening currently on AppMesh, but there is open request, a feature request for it. I think it's fundamental, and it's very cool. As we said, MTLS is supported only on Istio. Circuit breaking is supported only on Istio, but it's in the roadmap of AppMesh. Mesh visualization, I would say partly X-ray, and because Kiali also gives us configuration correctness and integration with Prometheus for all of the metrics. It's very cool. Kiali is very cool. Fault injection. So Istio lets me do some chaos engineering and inject delays and errors, HTTP errors between microservices, so I can test their resiliency. Does not exist on AppMesh. Traffic mirroring was said. So that's it. It was really on the last minute, which is cool. Thank you. I'll stay for 10 minutes for questions on the chat. I'll do the best to answer. And I know CloudZone will just as regular as in any other meetups, frontal meetups, will contact you with the next 2 days to share with you more on the session, which is the materials and so on, and also some feedback, I guess. And I hope you enjoyed.